Hi, my name is Mike Scanlon, and this is Considerations for Nested Dashboards. ArcGIS dashboards come with a lot of power to present your topic with maps, graphs, and tables. In this session, we'll talk a bit about our subject matter, touch on the basics of dashboard configuration, and dive into the methods for some complex designs. Again, my name is Mike Scanlon. I'm a staff assistant and systems analyst with the U.S. Forest Service. I've actually been in application development for a number of years. I've been using GIS since the early 90s and been doing programming within the ArcGIS environment for most of that time. Over to you, Chris.
Okay, thanks, Mike. Thanks everyone for joining us today. My name is Chris Ringo, and I'm a GIS programmer analyst and a researcher at Oregon State University here in Corvallis, Oregon. Like Mike, I've been working with Esri software since around 1990, mostly in a variety of natural resource settings, including fish and wildlife, forest ecology, potential vegetation modeling and mapping, and most recently in wildland fire, with some industrial hemp work thrown in there as well. So I'm going to briefly describe our project to get folks oriented and to give us some context to the development of our dashboards. Okay, so let me start out by stating the obvious. Wildfires are getting worse. Of course, this is obvious if you live here in the western United States or in Australia, or Brazil or Argentina or even Indonesia for that matter. The last few years have seen a sharp uptick in large and destructive wildfires, not only in the US, but across the globe. Looking at this graphic by Headwaters Economics, you can see that the last 3 out of 4 years here in the US have been record-setting in terms of structure loss by wildfire, particularly here in the West. Certainly there are other costs to wildfire like loss of habitat and loss of recreational opportunity, loss of valuable forest timber. But in this work, we're really zeroing in just on structure loss in particular, and here in the continental US. The most destructive wildfire in recent years here was the Camp Fire a couple of years ago, which burned through Paradise, California, destroying almost 20,000 structures. Looking just at this recent 2020 fire season, California fires alone accounted for more than 10,000 structures lost. The photo here is of the Woolsey Fire in Southern California. Even here in Western Oregon, where we live, this past fire season was a record setter. We had several very large fires that burned down the west side of the Cascades into the Willamette Valley and in southwest Oregon and destroyed more than 4,000 homes. For what is usually a very wet environment here in Western Oregon, these were very unusual fires. So the impacts of these recent fire seasons on people, on property, on fire suppression budgets within public agencies, they've really stimulated wide-ranging policy discussions within the Forest Service in particular about the role of active forest management to reduce hazardous fuels. So led by Alan Ager of the Forest Service's Rocky Mountain Research Station, we developed something we called the Fireshed Registry. It's intended as a planning framework for tracking changes in landscape condition with respect to wildfire exposure at several scales, at the forest scale, regional scales, and the national scale, while providing access to a variety of data describing past, present, and future trends regarding wildfire exposure to communities and forest and fuels management. So the first order of business in creating this planning framework was really to figure out what sort of assessment units were appropriate for what we were trying to model, which was fire exposure to communities. So we started with an exposure map that we had created from modeled fires and log transformed and smoothed it to get the kind of overall view of what community exposure looked like across the US. That's the map we're looking at here. And then we used a process called image segmentation, which goes through your image to come up with units that are relatively uniform in size and in color. So in this particular map, the colors are related to the community exposure. And so we use that to delineate our fire sheds. The details of that process can be found at the link at the bottom of the slide here. Now, as I mentioned earlier, this assessment is concerned with presenting information at multiple scales. So this slide is a bit busy, I know, but it's meant to illustrate that multi-scale nature of our application. So in addition to the fire sheds, we also use the image segmentation process to delineate finer scale assessment units nested within those fire sheds, which are called planning areas. You can see those in that middle inset on the map there. The main map shows the fire sheds, and the underlying exposure is symbolized from red to blue, high exposure to low. You can see that if you look at the top couple of categories in the legend, about 80% of the exposure in the continental US comes from only 5% of the landscape. And looking at the bottom class, 80% of the area only contributes 3% of the overall exposure. So the fire sheds give you that kind of broad assessment level view. If we drill down to the planning areas in that middle inset map, those are intended more as the prioritization implementation level. So they're roughly the scale at which national forests conduct vegetation and fuel management projects. So you might ask a question like, okay, we want to develop a 10-year plan to put in treatments to reduce fire exposure to communities to get the best bang for our buck. How would we do that? What areas would we target? Where would we start? So in that middle inset, the planning areas are shaded to depict one possible assessment. The project shaded red at the highest exposure and would be prioritized in year 1, going down the scale to the blue projects in year 10. And then finally, the finest scale, what we call stands or treatment units. At this level, we have refined exposure data. We have information on things like whether it's forest, shrub, or grassland, the ownership, whether or not it can be managed. So for example, if it's wilderness, we can't do any forest management activities, that sort of thing. So once we created this hierarchical system of assessment units and loaded it up with our data, we started to consider then, well, what do we do with it now? How do we present the data? So to start, I just mocked up a map atlas page, kind of a baseball card view for a single fire shed. In this example, we show a fire shed along the Colorado Front Range. And in it, we report out things like the community exposure that results from fires in that fire shed, large historic fires that have occurred there, the largest simulated fires and how many buildings they potentially could expose. What's the ownership makeup of that unit, the fuel types, that sort of thing. But it's a single static view and it's not easily updatable. We're not about to print off 7,700 pages of an atlas and hand it out. But we floated this page around and it was enough to get the attention of the Forest Service leadership and say, we really would like to see this developed further. So our first attempt in moving beyond that static atlas page was to move everything into a dashboard. It was pretty much designed at first using the same sort of baseball card type view. This time you'd be able to update the data though by clicking on a fire shed. Then it would update tables, which would give you the prioritized project list for the fire shed. You'd get the map with all the layers like the historic fire perimeters. You could see how much exposure you could potentially mitigate if you treated these particular areas. But in the end, it ended up being really cluttered. As you can see, it's disorganized. We really couldn't fit everything on it that we needed to. I mean, at this point, it was too busy and we had a lot more data to add. So at that point, we decided that we really needed an organizing principle. And we decided kind of a past, present, and future view as the organizing principle we would use to develop the data from this point on. So, for instance, how has wildfire affected that area in the past? What are the present conditions, the fuels, the ownership, that sort of thing? And then are the currently slated management activities that are scheduled into the future, how likely are they to actually mitigate some of the exposure? So at that point, we realized that we really needed to present our data on multiple dashboards and that we needed to link them somehow. So at this point, I'm going to turn it back over to Mike, and he'll take you on that journey.
Thanks, Chris, for that overview of the Fireshed Registry. I've got two different designs that I want to show you, but first, let's take a look at the basics of dashboard design. The first thing that you do with any dashboard is to add design elements. Your first element is normally a map. Chart, gauge, list, indicator, and details elements must be built on a layer file. It's easiest to get your layers from a map reference, but you can also select layers that are not in your map. Notice the last element, embedded content. That's where we can reference another dashboard. Each type of element will have unique configuration screens. After your elements are in place, you can always go back to the configuration and fine-tune the inner workings. Once you've added components, you can go back to the configuration of the dashboard itself. There you will find URL parameters. With URL parameters, you can design your dashboard to open in a specific context. You might open the dashboard from your own web page. You can open your dashboard from other ArcGIS Online content, such as a story map or a hub site. But you can also open one dashboard from another dashboard. This is what we mean by nested dashboards. URL parameters need a layer and a field name to act upon. That's why you add elements before you configure URL parameters. Once you select the layer, you can configure different actions and targets to respond to your URL parameters. In order to configure a dashboard as embedded content, you reference the dashboard's URL with a parameter. The general format uses the syntax of parameter equals a selected item. Here you see P1 equal Fireshed ID. One dashboard can have multiple parameters, but we didn't have to explore that design for our example. Dashboard actions can set context in a map by selecting a feature and zooming to that feature. Dashboard maps are also components that can include actions that are fired when a feature is selected. So those map actions are not executed when a feature is selected by a dashboard action. This is what we mean when we say that actions do not cascade from the dashboard selection to the map selection. Many times charts are used to sum acres from a selected map layer. That can be a problem with an embedded dashboard. Our design also included multiple embedded dashboards. A dashboard cannot signal a change to a sibling dashboard, only to its children. We also noticed that sometimes our Fireshed ID was a number and sometimes it was a string. Calling a string value from a number field or vice versa does not work. Now we're moving on to our next iteration of the dashboard design. This slide is a PowerPoint representation that I used to keep track of which dashboard was providing which content. Let me step through the list of dashboards in the outline on the left side of the screen. The master frame is represented by the pink outline. That page was built in ArcGIS Experience Builder. The master dashboard contains 4 primary tabs. The first tab on the app, Current and Historic Conditions, is represented by the red frame in this image. Within that tab, each of the white boxes are design elements configured in the Current Conditions dashboard. On the left side of this layout, 3 of those white boxes are actually embedded dashboards. Those dashboards each have multiple overlapping displays. If that part of the canvas had just one display, there'd be no reason to create embedded dashboards. On the right side of the layout, the additional colored rectangles were used to represent the additional tabs that again belong to the master page. This is just my effort to keep all of the dashboards straight. And this is the layout when you start up the dashboard in ArcGIS Online. The global dashboard, number 1, is represented by the title bar. The Current and Historic Conditions tab is the startup screen with 3 different map displays represented by 3 tabs under the map panel. On the left half of the screen, there are 3 nested dashboards represented by the numbers 3, 4, and 5. These dashboards are embedded in or children of the Current and Historic dashboard. The primary value of those nested dashboards is the ability to create stacked content on different parts of the canvas. The only stacked content that is technically part of dashboard number 2 is the map panel. The stacked content represented by tabs 2, 6, 7, and 8 actually belong to the master page. Nested dashboards let you build multiple stacks on your canvas. And these are the 4 top-level dashboards that were embedded content in the master page. In the top left corner is the image for current and historic condition. This was by far the most complex of the dashboards. A Fireshed selection on the top-level map was used to set context for 3 maps, 2 charts, and 4 lists. However, as we move to the other displays shown here, there was no way to put these dashboards in the same context with map extent or Fireshed identity. These displays were all children of the master dashboard. As siblings, they cannot talk to each other without customized programming. Just to reiterate, the primary advantage of nested dashboards is the ability to create stacked content in 2 different parts of the canvas. There are 2 text elements and 4 different list elements in this display. The circled text at the bottom allows the user to alternate between different list elements. This display takes at least 2 dashboards. The left stack is in one dashboard and the right stack is in another. So finally, when you put it all together, each of the circled areas on this slide represent parts of the canvas where the user can alternate between displays. This is a powerful way to conserve real estate, but it can be demanding for the users. You just about need to work in this interface daily in order to remember where to look for different content. And that just wasn't the experience of our user base. Now I'm going to move on to our final design for the dashboard. In this design, we're working with just one integrated dashboard. The first display is what we call the Navigator tab. The purpose of this tab is to orient the user and direct them to make the Fireshed selection. Our objective was to drive 45 different actions based on just one spatial selection. Now when we make a selection on this top map, it will propagate through all of the other tabs, maps, charts, and lists. All of the complexity that we hope to handle in the previous dashboard is handled in the actions associated with the selection of Fireshed on this map. So once you've made the navigation selection, there are 6 other tabs that are included. Each one is zoomed into the context of the same Fireshed that was selected on the Navigator tab. The top left display was our throwback to the baseball card design. The other tabs present the past, present, and future for the selected Firesheds, plus a tab that's dedicated to displaying information at the community level. The lower right display is the only other place where a selection is required. There, we are selecting a specific community. Also notice the boxes with yellow backgrounds. These parts of the canvas represent data sets where the user can select specific features to have them highlighted on the map. Here, so let me show you what I mean. The fire simulation database, FSIM, includes many different fires that affect homes in the Morrison, Colorado Fireshed. The action from the navigation map selected fires that intersected the Fireshed. So they could come from anywhere, but as long as they burned in that Fireshed, they would show up here. That was still a confusing mess of features. So here I can click on individual rows in the list of fires, these purple rows, and display only the selected fires. Interaction like this would be impossible if one of the components were managed as embedded content. Eventually, my partner Chris created another dashboard, Fireshed Investment Portal, to display the top 10 firesheds for states and Forest Service regions. On our planned and proposed treatments tab, the top right box allows us to launch Chris's dashboard and zoom into the Morrison, Colorado Fireshed. Of course, Chris had to configure a URL parameter on his dashboard to act on Fireshed ID with pan and zoom actions. This may look like a simple text element, but in order to add the URL parameter, this is a list element designed to display a maximum of just one feature. And here we see the key element for configuring that. For my list element, I write out all the verbiage that tells the user where they are going, Then I highlight the text I want to link and paste in Chris's dashboard URL as the target. Finally, highlighted in blue here, I edit the URL to add his URL parameter name and set it equal to Fireshed ID from my list's data elements. If you're comfortable with HTML, you can switch to the source display of the list text. There you can see the HTML code and add target equals blank to the anchor tag. That will ensure that your target dashboard opens in a new window so the user can return to the original content. For my second tip, you may have noticed that the Fireshed ID has a 1000 separator in the label. We left it that way to demonstrate an issue. Fireshed ID was generated as part of the image segmentation process. After we created Firesheds, this work pulled in data from many different sources. Researchers generated summaries and averages based on the Fireshed boundaries. Our related data sets were first uploaded as tables instead of feature classes. Configuration of display for data items in display elements occurs in the pop-up configuration for a layer. Feature layers have pop-up configuration, but tables do not. We experimented with adding a text field to the data set and calculating the text as the string representation of the Fireshed ID. We eventually created a point layer from the centroid of each Fireshed. We never display those points, but we attach our related data tables to the points, and that makes it possible to configure pop-ups for those data. Adding simple geometries to your data design will often give you greater functionality in the ArcGIS environment. So just to recap, we have the nested dashboard design that allows you to have multiple stacked windows. You can have multiple areas on the canvas with different stacks of content. You execute that by adding an embedded content element. Within the embedded content configuration, you design a URL parameter that your second dashboard will use to set context. However, only actions that can be configured as part of the URL parameter will be fired. Other dashboard actions will be ignored. We didn't really discuss this last point, but separate dashboards can reduce the network bandwidth required at startup. With the integrated design, there's only one part of the window that you can use for a stacked panel. In our case, we used the whole canvas. Grouping and stacking components to create tabs does take trial and error. We were able to trigger all of the Fireshed actions of this dashboard from one map selection. The integrated design allowed components to continue to interact and create a rich user experience. We touched on two special tips. The first tip was that referencing an external dashboard can be done with a text element. However, if you want to add context to the other dashboard, you'll use a list element and configure it to display only the selected record. The second tip involved formatting numbers in tabular data. If you don't have a geometry attached to your table, ArcGIS Online does not provide any way to format your field numbers. The default display for number fields includes 1000 separators. We didn't want that for Firesheds, so we tried building some tables with Fireshed ID as text. Then we got into trouble with numbers trying to equate to strings and vice versa. Finally, we just added Fireshed centroid points to the supporting tables. We never displayed those points, but that allowed us to configure pop-ups to get the displays that we wanted. This has been a pre-recorded presentation. We'd love to take questions, but I don't know if that will happen. I do want to say thanks to our ESRI hosts for allowing us to share our work.